7.1 Basic Trig Identities. Our objectives for today are to identify and use reciprocal identities, quotient identities, and Pythagorean identities. So let's get started. We're going to start with example 1. Provide a counterexample. For sine x sine x times cosine x, which will then equal tan x. So we're trying to provide a counterexample for this identity right here. Because the way this works is it's supposed to be, if you were to plug in like say sine square root of 2 and then cosine square root of 2, it would equal tan square root of 2. So when you would do sine square root of 2, for instance, it would be 1, I believe. Or not 1. It'd be so you'd have sine square root of 2 over 2, and then you'd have cosine square root of 2 over 2. When you multiply those together, you would get 1/2. So and that would equal to tan square root of 2 over 2, which would be 1, which would not work. That would be our counterexample. So I will show you. So we have to do this in radians in order for this to work, or degrees. It doesn't matter. So I'm gonna do radians. So I'm doing sine pi over 4 and cosine pi over 4 equals tan pi over 4. And we're trying to find a counterexample for this, not an example for this. So, like I said before, sine pi over 4 is square root of 2 over 2, and cosine pi over 4 is root 2 over 2. Equals tan pi over 4 would be 1/2, would be 1. Because the square root of 2 over 2 divided by the square root of 2 over 2, since tan is sine over cosine. And the square root of 2 over 2 times the square root of 2 over 2 is 1/2, which cannot equal 1. So that would be your counterexample. So let me pull up another page. So that's how you would work with Pythagorean, or with just a counterexample. So now we're going to work with a reciprocal identity. So a reciprocal identity apologize for my handwriting. Would be like sine theta, not O, equals 1 over cosecant theta. And just like that, that's how that will work. And you could do it the other way, since this is called a reciprocal identity. So you could do cosecant theta equals 1 over sine. So let's say I have tan theta. What would that equal? Need to pause the video. It'd be 1 over cotangent because of the reciprocal identity. Same with cotangent theta equaling 1 over tan. And that applies for every trig identity right here. So also cosine theta equals 1 over secant theta, and secant theta equals 1 over cosine theta. So that is our reciprocal identities. Now I'm going to show you our quotient identities. So our quotient identities are what I've actually talked about already. God, I can't spell. So sine over cosine, like I said before, is tangent theta. So this would work the same for cotangent actually. Just by looking at it, what do you think cotangent would be? Because tangent is 1 over cotangent, so and tangent is sine over cosine. So cotangent would be cosine theta over sine theta. It's just the reciprocal. And then last but not least, we'll do Pythagorean identities. So a Pythagorean identity is a lot trickier than all these other ones, believe it or not. Just like the Pythagorean theorem, how it's a squared plus b squared equals c squared, this works kinda the same way. So you have sine squared theta. Oops. Hold up. Let me erase that. Start that over. So you have sine squared theta plus cosine squared theta. It would actually equal 1. And with these other identities, tan, let me space that out more so you guys don't get the wrong idea. And you'd have tan squared theta plus 1. So this is a total different new identity for it, for the Pythagorean, equals secant squared. Don't ask me how, that's just how it works. And you can apply this to actual problems, which I will show. And then you have 1 plus cotangent squared equals cosecant squared. So we're going to do an example of this. We're going to start with reciprocal identity. So we're going to get a new page, and we're going to go as follows. This is going to be a secant 3 over 2 equals 3 over 2. Got to put the theta. And we need to find cosine. So with the reciprocal identity, what you're going to do is you're going to use the reciprocal identity for cosine. So cosine theta equals 1 over secant theta. So we would substitute the 3/2 for secant, not cosine. So it would be cosine theta equals 1 over 3/2, since secant equals 3/2. And then if you do the math, you will equal it up to 2/3. So cosine theta equals 2/3. We'll do another example. So we're going to use cosecant theta equals 4/3, and we need to find tan. So what you're going to do is you're going to use the Pythagorean identity. Since you can't do a reciprocal identity for this, but we do have a Pythagorean identity. So we're going to use the Pythagorean identity cosecant squared plus, or my bad. You can switch it around, actually, and make it do this, equals 1 plus cotangent squared theta. It's the same concept as 1 plus, yeah, you get it. It's just flipped around. So you're going to plug in 4/3 into cosecant. So you got 4/3 squared equals 1 plus cotangent squared. And then you're going to have that squared, so it's going to be 16 over 9 equals 1 plus cotangent squared. Then you're going to subtract the 1, and that's going to give you 7/9. Then what you're going to do here is you're going to square root the problem on both sides. So you're going to square root 7/9 and square root cotangent squared in order to make it cotangent. So you're going to end up with plus or minus the square root of 7 over 3, which equals cotangent theta. And that is it. So just to recap what we went over today, we went over 7.1 basic trig identities. We learned how to identify and use the reciprocal identity, which is right here. And then we identify quotient identities, boom, right there. And then we identify Pythagorean identities. And we use them in actual problems, as you can see. Thank you all, and have a nice day.